Okay, let's look at a couple of long division problems. This is probably something that has been lost because of the calculator, right? So if you take something like this and you just plug it into a calculator, you don't get the true answer, meaning how many times it goes in and the remainder. And sometimes the remainder is important. Like let's say that this is you're making something and they go in packages of 5. How many packages do I need and how many are left over, right? So that kind of thing. So what I look is I first see, will 5 go into 3? Nope, because 5's bigger. So then I look and I see, will 5 go into 36? And I kind of go through my multiplication, or I get my multiplication table out, and I know 7 times 5 is 35. If I picked 6, 30, then my remainder would be larger than that value. So that's how you know you have to go to the highest value that will go in here. So now I do 7 times 5, which is 35. I subtract this line and that becomes 1, and then I bring down the next value. And so I see, well, 5 times 4 would be 20, so that's too large, but 5 times 3 is 15. And now this gives me my remainder of 4. And so as I was mentioning, I could go to my boss and I could say we need 73 packages, and 4 is going to be left over that will not, we either put 4 in a package of 5 or we just don't use those 4. And so that's why I know a lot of times students are always like, yeah, I can get calculators to do this for me, but you want to be careful to know if you have something with remainders. So let's do something a little bit crazier. So let's say I have, they're telling me to divide 42,191 divided by 306. And I'm having to do this by hand. So that's this. 42191. All right. So what I do is I know I need to look what's going to go into something larger than 306. And that's going to be the 421. I know it's only going to go 1 times. How do I know that? Because if I take 306 times 2, saying 2 times, that's what's 12, 612, and that's too big. So I know it only goes 1 time. So I have 306. So now I subtract this line. 6 goes into 1. I need to make that 11. So 5, and I borrowed 1 here. And then 4 minus 3, which is 1. And now I bring this next value down. Now this gets a little more difficult, right, without a calculator. But I already know 306 times 2 is 612. So let's see what 306 times 3 would be. So that's 18. 9. So that's looking pretty good. And I could go ahead and try that. Meaning, let's do 3, 9, 1, 8. How will I know if this works if my remainder is smaller than this value? And I can kind of already tell because 9 goes in 11 2 times. So 9 minus 8, which is 1. 5 minus 1, which is 4. And then the 2, I bring my next value down, 1. And now I can see I'm going to need something larger, right? Well, I kind of look at this and I think, what about 8? And you're probably going, why? And I should be doing better with this and this multiplication. Why is she seeing 8? My eyeball sees that 8 times 3 is 24. I was kind of looking at that piece. So let's see what happens here. 8 times 6 is 48. So of course that's 0, and then 24. So I can see that's too big. So I know I'm going to use 7. And so I do my 306 times 7. 7 times 6 is 42. And so I'm going to have 2142. And I subtract this. That'd be 9. And of course I had to borrow 1 here. Going to have to borrow 1 there. And so that's going to be into 10. So 6 I'm getting where I can't read my handwriting, and that was a 3 that I borrowed there. So that would be 2, which is smaller than that value. So whatever I'm dividing this into, like a real world problem again, maybe it's we have this many students and we have school buses, these big buses that you can fit 306 students on. How many buses do I need? I need 137 buses, and I'm going to have one bus that's only going to have 269 students. And so again, you know, if you start to learn why are you having to do this by hand to get remainders, you're always thinking of this leftover here, this remainder. What would it represent? And in this case, the leftovers.